Imagine this. A company spent $17 billion building one of the most advanced semiconductor factories in the United States. The construction is finished. The clean rooms are ready. Thousands of engineers have been hired. The production lines have been installed. From the outside, everything looks ready. But if you walked inside that factory, you wouldn't see thousands of chips rolling off the production lines. You wouldn't hear machines working at full capacity. In fact, you'd find one of the world's most expensive factories waiting. Not because it ran out of money, not because the engineers made a mistake, not because there wasn't enough silicon. The factory was waiting for something much smaller, a handful of machines. That might not sound unusual at first. Factories wait for equipment all the time. But these weren't ordinary machines. Each one was worth hundreds of millions of dollars. Each one required years of engineering to create. And without them, a factory worth billions of dollars couldn't build its most advanced chips. This wasn't a movie. It wasn't a fictional story. It happened to Samsung's new semiconductor project in Texas, where deliveries of some advanced lithography equipment were delayed, slowing part of the project's timeline. Which raises an interesting question. How can a single machine become so important that one of the biggest technology companies in the world simply has to wait? To answer that, we need to go back to the beginning. Not to the beginning of Samsung, not to the beginning of ASML, but to the beginning of every computer chip ever made. So, what exactly is a computer chip? Most people picture a tiny black square inside a phone or a laptop. It's small enough to fit on the tip of your finger, easy to overlook, almost impossible to appreciate. But that tiny piece of silicon is one of the most complicated products humans have ever manufactured. Inside it, there aren't hundreds of components, or thousands. There are billions. Tiny electronic switches called transistors. Each one has a simple job. It can either allow electricity to pass or stop it. That's it. By themselves, they're incredibly simple. But when you place billions of them together, they can do extraordinary things. They can recognize your face, translate languages, generate images, train artificial intelligence, launch rockets, and perform trillions of calculations every second. The strange part is, designing those transistors isn't the hardest challenge anymore. The real challenge is building them. Imagine someone asks you to draw a perfect city, not on a piece of paper, but on something smaller than your fingernail. Every street has to be perfectly straight. Every building has to be in exactly the right place. Every tiny mistake could ruin the entire city. Now make that city thousands of times smaller. That's much closer to what chip manufacturers deal with every day. And every few years, they make everything even smaller. Why? Because smaller transistors allow more of them to fit onto the same chip. More transistors usually mean more computing power. Smarter smartphones, faster computers, smarter AI, more efficient data centers. And that created a race. Every major chip company wanted to build the next generation before everyone else. For decades, they kept winning that race, year after year, generation after generation. Engineers found new ways to make transistors smaller. Until one day, progress started slowing. Not because companies stopped investing. In fact, they were investing more money than ever before. Not because engineers ran out of ideas. Some of the smartest scientists in the world were working on the problem. The problem was something much harder to negotiate with: physics. The tools that had built generations of computer chips were reaching their limits. And if the industry couldn't find a completely new way to manufacture chips, the incredible progress that powered modern technology could begin to slow. So the biggest question in the semiconductor industry became, how do you print something that's almost too small to see? And answering that question would eventually lead to one of the most complex machines ever built. So, how do you actually build something that's almost invisible? At first, the answer sounds surprisingly simple. You print it, not with ink and not on paper. You print it using light. This process is called lithography. Imagine shining a flashlight through a stencil. Whatever the light passes through gets projected onto the surface behind it. Chip manufacturing follows the same basic idea. Instead of printing letters, it prints microscopic electronic circuits onto a silicon wafer, layer after layer after layer, until billions of transistors are formed. For many years, that method worked incredibly well. Every new generation of machines became a little more precise. The semiconductor industry kept moving forward, but eventually, engineers ran into a problem: the light itself. No matter how perfect the machine became, the wavelength of ordinary ultraviolet light was becoming a physical limit. And that's because light behaves in a very predictable way. Generally speaking, the smaller the details you want to print, the shorter the wavelength of light you need. Imagine trying to write your name with a thick paint roller. It doesn't matter how steady your hand is, the tool is simply too large. Now replace that paint roller with a fine tip pen. Suddenly, you can draw much smaller details. Chip manufacturing faced the exact same problem. The existing technology had become the paint roller. The industry needed something much finer, something that for years many experts believed wasn't practical to build. That something became known as extreme ultraviolet lithography, or simply EUV. Instead of using conventional ultraviolet light, these machines use an extremely short wavelength of light, short enough to print features measured in just a few nanometers. It sounded like the perfect solution. There was only one problem. No one knew how to build a machine capable of doing it reliably. The idea was brilliant. Turning it into a real product was an entirely different challenge. For years, some engineers even questioned whether commercial EUV systems would ever become practical. But one company refused to give up. A company that most people had never heard of. A company based in a small European country. And over the next few decades, it would quietly change the future of the semiconductor industry forever. That company was ASML. If you've never heard that name before, you're not alone. Unlike Apple, ASML doesn't sell smartphones. Unlike NVIDIA, it doesn't design AI chips. Unlike Intel,
it doesn't manufacture processors. In fact, most people will never own a single product with the ASML logo on it. So why is it one of the most important companies in the technology industry? To answer that, we need to look inside one of its machines. From the outside, an EUV machine looks like a giant piece of industrial equipment. It's enormous. It fills entire rooms. Installing one isn't as simple as unloading it from a truck. It has to be transported in hundreds of separate modules, then carefully assembled inside the factory. Every step has to be almost perfect because this isn't an ordinary machine. It's one of the most precise manufacturing systems ever built. Inside, thousands of engineering systems work together. Powerful lasers, ultra-precise mirrors, vacuum chambers, motion systems that move silicon wafers with astonishing accuracy. If just one critical component is slightly out of alignment, the entire process can fail. Now, here's what makes the story even more fascinating. ASML didn't build this machine alone. No company could. Building an EUV system requires technologies developed by specialized suppliers from different countries. One company produces some of the world's most precise mirrors. Another develops advanced laser systems. Others manufacture sensors, motion control equipment, and highly specialized components. ASML brings all of those technologies together into a single machine. Think of it like building a Formula One car. One company makes the engine, another designs the tires, another builds the electronics, but someone still has to integrate everything into a car capable of winning a race. That's essentially what ASML does, except instead of building race cars, it builds machines that make the world's most advanced computer chips possible. And because building those machines is so difficult, there isn't a long list of competitors offering equivalent commercial EUV systems, which means that when a company wants to manufacture the most advanced chips available today, there's one name it almost always ends up dealing with: ASML. But if these machines are so valuable, why have they become the center of one of the biggest technology conflicts in the world? The answer has very little to do with business and everything to do with power. At first, computer chips were simply a business. Companies competed to build faster processors. Consumers bought better computers, and everyone moved on. But over the past decade, that changed because chips stopped being just another electronic component. They became the foundation of almost everything. Every AI model, every modern smartphone, every advanced fighter jet, every satellite, every supercomputer, and even many medical devices all depend on increasingly powerful semiconductors. Suddenly, the question was no longer who makes the best chips. It became who has the ability to make them at all. That's when governments started paying attention. The machines inside semiconductor factories were no longer seen as ordinary industrial equipment. They became strategic assets. Owning them meant technological leadership. Not having access to them could slow an entire country's ambitions. This is why the conversation around ASML eventually moved far beyond business. It entered the world of geopolitics. Countries began debating who should be allowed to buy the company's most advanced machines. Export licenses became international news. Diplomatic meetings included discussions about semiconductor equipment. And one company that had spent decades focused almost entirely on engineering suddenly found itself at the center of global politics. Think about that for a moment. ASML doesn't manufacture smartphones. It doesn't create AI chatbots. It doesn't sell laptops. Yet decisions about its machines can influence which companies and even which countries are able to produce the next generation of advanced chips. That's an extraordinary position for a company that many people had never heard of. But here's something even more interesting. ASML didn't become important overnight. It wasn't the result of one brilliant invention or one lucky decision. Its position was built slowly, year after year, decade after decade. While most of the world was paying attention to the companies launching exciting new products, ASML was solving manufacturing problems that almost nobody else wanted or was able to solve. And that's a pattern you'll find again and again in business history. The companies that attract the most attention aren't always the companies creating the deepest impact. Sometimes the greatest influence belongs to the company working quietly behind the scenes. The company that doesn't build the final product, but builds the tool that makes the final product possible. And that may be the most valuable position of all. Now, let's go back to where this story began. A factory worth billions of dollars standing still. Thousands of engineers ready to work. Customers waiting. Production lines prepared. Yet nothing could move forward. Not because the factory was missing workers, not because it was missing money, but because it was waiting for one machine, a single machine. When most people think about the technology industry, they think about the companies they see every day. Apple, NVIDIA, Intel, AMD, Qualcomm. They're the names on the products we buy, the companies in the headlines, the brands everyone recognizes. But every one of those companies depends on something much less visible, a manufacturing ecosystem so complex that even the world's richest companies can't simply recreate it whenever they want. That's what makes ASML so remarkable. Its greatest achievement isn't that it builds expensive machines. It's that it spent decades solving engineering problems that almost nobody else ever attempted to solve. And in doing so, it quietly became one of the most important companies in the global technology industry. There's an interesting lesson hidden in this story. In business, the company selling the final product isn't always the one with the greatest influence. Sometimes the most powerful position belongs to the company building the tools everyone else depends on. The company almost nobody talks about can end up shaping the future of everyone else. So the next time you hear about a revolutionary AI model, a faster smartphone, or a record-breaking computer chip, remember that before any of those products could exist, someone first had to build the machine that made them possible. And in many of those cases, that machine came from a company that quietly changed the world without most of the world ever noticing. ASML, the company that doesn't make the chips, but helped make the age of advanced chips possible.